Hello everyone. In this lecture, we are going to learn about normalization of data in a multi-criteria decision-making problem. In the first lecture on multi-criteria decision-making, we were solving this problem where we had about 6 criteria here. And then we had 3 alternatives, and we were trying to solve this multi-criteria decision-making problem of choosing one phone based on these 6 criteria, right? And initially we did the solution without any weights, and there we saw that the iPhone has the highest score, so it was just simply based on rating and then taking the average of the rating, okay? But then we introduced weight for different criteria because we might have different priorities for different criteria, right? And then we were multiplying each of these scores rating for the alternatives under each of the criteria with the weight of the criteria, okay? And then we saw our results change slightly, and here we had the Samsung as the best alternative, right? So this was our problem. But also here we say that we can use data on different scale or unit of measurement in a multi-criteria decision-making problem, and which is one of the benefit of using multi-criteria decision-making problem. For example, here for price, we can use the real price data. Okay, so for other criteria, we are maybe using 1 to 9 scale, where 1 means like poor and 9 means really good. But for price, we can maybe use the real data. For example, if I put 900 here, and then here I put 1300, and here I put 600. Okay, so let's say this is our price, real price data, right? And we can actually put real data for different criteria as well. But here we will just use real data of one criteria, and others we will still keep it into 1 to 9 scale. Okay, but the process I'm going to show you, you can apply it whenever you have different types of units of measurements for different criteria. So you can just add up to it and it will not be a problem at all. Okay. So as soon as I put the real price data, we see that here, we see that our scores, they change here because I have the calculation there already, so our scores change. And here we see that iPhone is really one of the best alternatives, right? And it differs, it is quite high ranked in terms of score difference from Samsung and also quite a lot from Nokia. But here one thing happened. The other criteria, the higher it was, it meant good. Okay, it meant the criteria, this phone is good for this criteria. But here for price, actually it's not the case. The higher the price is, for the buyer or for the decision maker, it's not good, it's not beneficial. Okay, so for example, here when it was 9, here it was beneficial. The style iPhone is great, so it was beneficial. But the price 1300, it's too much, it's not beneficial. Okay, so this is one more thing we have to understand, whether the unit of measurement, if it's a beneficial or non-beneficial unit of measurement. Okay, so that's one thing you have to understand. And here we know, okay, price is non-beneficial and other criteria are beneficial. That's what we know. Now, to really do a meaningful analysis, because this is not really meaningful, here we have different unit of scale, and taking the average of this doesn't make any sense. So to really make a meaningful analysis, we have to normalize this data. And there exist quite a lot of different approaches to normalization, but there are mainly 2 commonly used ones. One is linear normalization and another is vector normalization. So these are the 2 widely used, common used approaches. Okay. But in this lecture, we are going to focus on the linear normalization first, and in the next lecture, I will show you the vector normalization. Okay. So for linear normalization, let's look into the equations. So first of all, we have to decide if it's a beneficial or non-beneficial. So let's say, first of all, if we look into the beneficial one. So when 1 is greater than 10, then 1 is non-beneficial. So when 1 is greater than 10, then 1 is non-beneficial. So let's say first of all, if we look into the beneficial one. So first of all, if we look into the beneficial one. So let's say first of all, if we look into the beneficial one. So when 1 is greater than 10, then 1 is non-beneficial. So let's say first of all, if we look into the beneficial one. So when 1 is greater than 10, then 1 is non-beneficial. So let's say first of all, if we look into the beneficial one. So when 1 is greater than 10, then 1 is non-beneficial. So let's say first of all, if we look into the beneficial one. So when 1 is greater than 10, then 1 is non-beneficial. So let's say first of all, if we look into the beneficial one. So when 1 is greater than 10, then 1 is non-beneficial. So let's say first of all, if we look into the beneficial one. So when 1 is greater than 10, then the criteria is a beneficial one, then we can do the normalization. So if I denote it, the normalized values with xij prime or bar, whatever you want to call it, then what we will simply do is we will divide each of the values, each of the rating of an alternative under an criteria with the max value, under that criteria. Okay, that's what we are going to do. And if it's a non-beneficial criteria, then we are going to use more or less the same equation. So if I denote again with xij prime, what we are going to do is 1 minus xij divided by the max value of that criteria. Okay, so this is going to be our equation. Okay, so here by I we denote, by xij we denote that it's the rating of an alternative under a criteria J, rating of alternative I under criteria J. Okay, so we explained it in our lecture on basic notations in multi-criteria decision making, right? So now let's have a look how to really solve this issue. Okay, so first what I'm going to do, I'm simply going to copy this whole thing. I'm just going to copy it and I'm going to paste it, let's say here. And here I'm going to say normalized solution. Okay, so here I'm calling it a normalized solution. Great. And here this is the part I'm going to remove, because only this is the part is going to change. Other part of the calculations and multiplication are going to remain the same. Only this is the part where we have to normalize the scores. Okay, so the first criteria here is the quality, and here quality is a beneficial criteria, right? So what we are going to do is we are going to select the value of the first alternative under criteria quality, and we are going to divide it by the max value, okay, by the max value of all the values in that criteria. So these are the values in that criteria, right? And we are going to close our bracket. And here it's a good idea to fix it, because we are going to drag it. So if I fix the value, so we are going to drag the equation. We want all the values, all the ratings under each of the alternatives to be divided by the max value of this range of values in the quality. So we just fix these values using F4. Okay, and it could be a slightly different command in your computer, but mine is F4, or you can just put the dollar symbols manually by yourself. Okay, so that's what we did. We just dragged it. So now this value is also divided by the max value of this. Okay, so the max value we can see here, it's a simple problem, few alternatives. We can see that it's 8, and we divided by 8 actually, all these three values. Now let's come here. Here it's a non-beneficial criteria. So here what we have to do, we have to go for 1 minus, and then we kind of start a bracket. Okay, and then here is our value, and this value has to be divided by max of this range. Okay, max of this range, and we close the bracket, we put another bracket, and here we are going to fix these values. Okay, and then we are going to drag it. Okay, so here, just to make sure that it looks nicer, we are going to have these 3 digits for all of them. Yeah, great. And then comfort and the others, all of them are again a beneficial criteria, so it is rather simple. So here we are just going to divide this by the max value of this range, and you have to remember to fix the denominator, right? And we are just going to drag it. Again, we just make it to 3 decimal points. Okay, and here one idea could be also, if you want to make it faster, you can just also drag these ones, because here we are not going to have much change. But then here we have to change the number of the row. Okay, so it should be 6. Okay, if I update the rows to 6, and this row it should be 7. So we see here it's D7, so it should be divided by the max value of the row 7, right? And then here it should be divided by the max values of row 8, right? Great. And then these 3 values we can select, and also we can drag them in this side. So now we have everything in place. Yeah, everything looks great. Yeah. And here we have the average score. So based on after normalization, based on only calculating the average of all the scores, this is the solution. Okay, and here we see that the iPhone is actually the best solution. Okay, but when we look into the normalized solution, while multiplying with the weights like here, and then after taking the multiplication, we take the average of it. In this case, we see the solution changes. Actually, this one becomes the best solution, and even the second solution is now Nokia, and after that the third solution is our iPhone. Okay, so you see, based on the weights we have here, and after applying the normalization, our solution changes completely from what we had here. But this is actually more meaningful solutions, and this is what is more logical. Okay, so this is how we can apply the linear normalization and get a more precise and accurate decision for our multi-criteria decision making problems. In the next lecture, I'm going to show you the vector normalization approach. Thank you for watching. If you have any queries, feel free to reach me. Thank you.